Hello and welcome back to m200 lecture series for Cañada College. We are using PowerPoint presentations created from Mario Triola's textbook, Essentials of Statistics, 5th edition. My name is Ray Lapuz. We are now in Chapter 3. Let us begin with a review and preview. Back in Chapter 1, we now know some important vocabulary for basic statistics. A parameter is a numerical characteristic of a population, and a statistic is a characteristic of a sample. We also discussed different sampling methods with the goal of finding the samples that are simple and random. In Chapter 2, we created frequency tables and graphed histograms to envision the center, variation, and distribution. So now we will continue our work on developing our ideas of center and variation. As we continue to preview the course, we'll see that statistics can be split up into two main parts. Descriptive statistics studies how we describe important characteristics of a data set. Later this semester, we'll study inferential statistics, where we'll be able to draw conclusions about a population based on a sample. Section 3-2, Measures of Center. The basic idea is to define some measure of center. There are several of them, but some of them may be more useful than others in certain situations. So this is what we will explore. Let's start with a basic concept. A measure of center is a value at the middle of the data set. So let's define some measures of center. The first measure of center we'll consider is the mean, or arithmetic mean. This is what we know as the average. We add up the numbers and divide by the number of numbers we added. As simple as this may be, we should take a look at the mathematical notation because it would be important for us to identify the mean as a formula. Here are some important notation. This symbol is called sigma. This is a Greek letter capital sigma, and the S stands for sum. This notation tells us we're going to add up some stuff. X is the variable that represents all the numbers in our data set. So sigma x tells us that we will add up the numbers in our data set. N represents the number of values in our sample. Capital N represents the number of values in our population. So now we have our first example of distinguishing a statistic from a parameter. Lowercase n is a statistic and capital N is a parameter. Speaking of statistics and parameters, we use the symbol x bar for the mean of a sample. Remember that sigma x adds up the number of numbers, then we divide by n. Now, for the mean of the population, we would divide by the number of values for the population. But note that we're calling this something different. We use the Greek letter mu. That's an M that stands for the mean. So when we're referring to the sample mean, we say x bar, and when we're referring to the population mean, we say mu. Let's try an example. Here we have 5 numbers, 22, 26, 24, and 23. To find the mean, we add up the values, then divide. Using the formulas, we get 17 divided by 5, or 23.4 chips. The mean is a really valuable measure for us in statistics. One of the main advantages is that this would be a good representative measure of a population. Later in the semester, we'll explore the idea of which parameters best match up with their corresponding statistics. Another important aspect of the mean is that it takes every single value into account. However, this can also be a disadvantage. A large change in an extreme value, like an outlier, can greatly affect the value of the mean. Another measure of center is the median. The median is the middle value when the data points are sorted in order. Some textbooks use the notation x tilde for this, but we won't. We'll just call it med, M-E-D, or simply use the whole word median. The other important property is that, unlike the mean, the median is not affected by extremely large or extremely small values. We call this a resistant measure of center. So how do we find the median? First, we arrange the data in order. Then, depending on the number of values, we'll go one of two ways. If we had an odd number of values, then there is a middle number. This is the median. If we have an even number of values, there are two middle numbers. To find the median, we will compute the mean or the average of these two middle numbers. Let's take a look at an example. Consider this set of numbers. The first thing we want to do is to sort them in order. With 7 numbers, we look at the middle value. That's the fourth number. So our median is 0.73. Here's another example where we have an even number of values. After sorting, we look at the two middle numbers. Then we find the mean of the both of them. Then the result is the median for our whole set. Another measure of center is the mode. The mode is the value that occurs the most. Depending on the data set, you may end up with more than one mode. Here are some common terms where we don't have exactly one mode. An important property for the mode is the idea that this is a measure of center that can be used for non-numeric data. For example, the average name in 1990 is James. This is to say that the most common name, the mode, is James. Let's take a look at some examples. In the first set, notice that 1.10 occurs twice. This is the most frequent, so this is the mode. For the second set, notice that 27 and 55 both occur 3 times. So we have 2 modes. In the next set, all the numbers happen exactly 1 time. So in this case, there is no mode. One more measure of center for us is the mid-range. This is essentially the mean of the smallest and largest value in the data set. Some notes on the mid-range. This only looks at 2 values in the data set, and it's quite sensitive to extreme values. Although it is very easy to compute, it is rarely used in statistics. This is often mistaken for the median, so make sure that you are able to use the correct measure. We'll see round-off rules throughout the text. For measures of center, the round-off rule is to carry out 1 more decimal place than what is present in the original data set. Let's take a look at a couple of more ideas for measuring the center. There are times where we might not have the original data set. Instead, we might have a frequency table or a histogram. We can't exactly calculate the mean, but we can estimate the mean. If we make the assumption that every value in each class is equal to the midpoint, then we can add up all the midpoints. We do this by multiplying each midpoint x by its frequency, then add it all up. The sum of the frequencies is like the total number of values, so this is like dividing by n. Here's an example. Here's the frequency table from Chapter 2. First, we find the class midpoints. Recall that you take the mean of the upper and lower class limits for each class. For the first one, the mean of 50 and 69 is 59.9. Next, you multiply the frequencies and class midpoints. Then, add them all up. Now you have the sum of f times x, and you have the sum of the frequencies is 78. Finally, you just divide and get the estimate for the mean. One more way to find a center is with the weighted mean. This is the way to compute your GPA, your grade point average. For each class you complete, the W would refer to the number of units and the X would be your grade, 4.0 for an A, 3.0 for a B, etc. Here's an example. For the 5 courses, she got an A in a 3-unit class, an A in a 4-unit class, a B in a 3-unit class, etc. So the weights are given here, and the X's are given according to the grades. And so we put these values into the formula, and we get the mean, which is her GPA. And her GPA is 3.07. Okay, that is the end of section 3-2.